How's it, grade 11s? We're going on to proving more complex identities. If you didn't think they were complex yet, well, we're going on to more hectic ones now. Okay, so we are working from slides 115 to 118 from the trigonometry PowerPoint. So the first question is just saying prove the identity. It would have this equal to this. I'm just saving space by breaking it down straight away, left-hand side, right-hand side. So as you can see, with both the left-hand side and the right-hand side, there's not much we can do. I mean, we've got 1 plus cos x, nothing we can do there. Sin x, nothing we can do. On the right-hand side, sin x, and at the bottom, 1 minus cos x. So we can't expand, we can't use any identities or anything like that. So what I'm going to do is I'm going to work with the left-hand side. We could work with the right-hand side, but just the left-hand side for simplicity. I'm going to multiply it by something called the conjugate. And I'm going to multiply by the conjugate of the top. Now, conjugate just means basically the opposite. So the opposite of this would be 1 minus cos x. If I multiply the top by that, I must multiply the bottom by it. Because essentially what we're doing here is we're multiplying by 1. Because 1 minus cos x over 1 minus cos x is 1. So we're multiplying by 1, so we're not changing this at all. And you can see, as soon as I've done that, look what I've introduced. I've introduced a 1 minus cos x at the bottom. And there it is. Okay. So at the top, I'm going to be using FOIL, first outer inner last. So 1 times 1 is going to give us 1. Then 1 times minus cos x is going to give us minus cos x. Cos x times 1 is going to give us cos x. So they're going to cancel because we have minus cos x plus cos x, they cancel. Then we've got positive and a negative gives us the negative. Cos times cos gives us cos squared over x. Oh, not over x, cos squared x, sorry. Over. Now the bottom I'm not going to multiply through. I'm going to leave it as sine x 1 minus cos x. And the reason for that is because I've got my 1 minus cos x. I want that at the bottom. Okay, now we need to try and get rid of this sine at the bottom because we don't have a sine at the bottom here. And I need to try and introduce a sine at the top because we've got a sine over there. This is where our square identity comes into play. So you know we have cos squared alpha plus sine squared alpha equals 1. We can get one of two things from this. And the one I'm interested in is the sine squared. Okay, so I'm going to make this 1 minus cos squared x sine squared x. So that becomes sine squared x over sine x minus 1 minus cos x. 1 sine x will cancel with 1 sine x there, and we're left with 1 sine x up at the top over 1 minus cos x, which is equal to our right-hand side. And we've proved it. Okay, moving on to example B. Again, the question is just prove the identity, and they would have had this equals to this. I've just broken it down straight away into left-hand side, right-hand side. So if we have a look at the right-hand side, there is pretty much nothing we can do there. We've got cos A minus sin A over cos A plus sin A, nothing we can do. So what I'm going to do is I'm going to work with this side here. And now this is where things get a little bit tricky now. Over here, I can see I've got cos squared minus sine squared. And I'm just going to do this on the side here. And you remember what I've done so far, grade 11s? For my little trick substitution thing, I let coses be x and I let sines be y. Okay, so that's what we've got there. We've got x squared minus y squared. That is a difference of two squares. And what I can do with that is I can factorize that to be x plus y, x minus y. So basically what we've got here is cos A plus sine A, cos A minus sine A. And have a look there, we've got a cos A minus sine A. So that is what we want from that one there. So I need to try and eliminate this one over here with something at the bottom. And I can see with this, we've got 1 plus 2 sine A cos A. What I can do with this one to try and make it something that we can factorize is I can get this 1 to be cos A squared plus sine squared A, all right, using our square identity. So I just want to write that here. So we can say that cos squared A plus sine squared A equals 1. So I'm going to substitute that 1 to be that. And this top, I can factorize so long using this here. So we would have cos A plus sine A, cos A minus sine A, over that. I'm going to change to this. So we're going to get cos squared A, and I'm going to put this term in the middle, plus 2 cos A sine A, and then I must still introduce my plus sine squared A. All right. Also what I've done is I've just swapped around the cos and the sine here, but it's the same thing. So if I use my little substitution trick for this one over here, what have we got? We've got x squared plus 2xy plus y squared. What does that look like to you? That is a trinomial. And if we factorize that trinomial, we're going to get x plus y by factorizing it. And that is what I'm going to do with this, is I'm going to factorize this as a trinomial, just like I've done here. So the top is still going to be cos A plus sine A, cos A minus sine A, over. Factorize this, and I'm just going to use my little substitution thing here. Remember, x's are cos, y's are sines. So we have cos A plus sine A, cos A plus sine A. All right, so let's look for things that can cancel. That cos A plus sine A will cancel with that cos A plus sine A. And what are we left with? We're left with cos A minus sine A over cos A plus sine A, which is what we wanted. So that's equal to the right-hand side. Okay, grade 11s. What I would like you to do is exercise 7.9, number 1 for me, please. Thank you.